me give some intro to this topic. Okay, those who are in the 6th grade, whatever topic we are going to discuss, those concepts you will get either in 7th or 8th grade. It depends upon the boards. Okay, in which board you are studying, it depends upon that. So it is also same similar topic based on the previous calculation, pattern. So that I'm included here. Okay, right. Let me give some vocabulary related to this topic. Okay, A, B, let me write small, A, B, C, up to so on Z. Okay, all these alphabets we are considering as a variables. What we are considering as here? Variables. How many members don't know about variables? Raise your hands. How many members don't know about variables? Okay, everyone knew it. Good, good. Okay, right. So, right here, suppose let me take variable A. Okay, variable A I'm taking. Okay, any multiple. Okay, here we are writing multiple. What we are writing here? Multiple. Multiple. Okay, here we are writing top of the A. Okay, here we are writing power. Okay, or exponent. Okay, exponent. Got it my point? Clear? Right. The multiple is called, what we call multiple here? Anybody knew? Coefficient we'll call. What we call? Coefficient. Coefficient, power or exponent to the variable. Okay. Right. Now, this total, okay, this total thing we will call in algebra is a term. What we call? Term. Clear my point? What we call?
Yeah.
Term. For example, 3a is a term. Okay. And for example, x, y, z all are multiplied to each other. This is also a term. Okay. Suppose 4x power 5. 4x in the power, I said power 5. So this is called also a term here. Whatever I written on the board, is it clear for everyone? Any doubt, please ask.
No. No.
Doubt? Am I right? You not understood?
No, I don't have any questions.
Okay, okay. So got it now? Right. So this is can please tell me you have to tell me what is the coefficient, okay? Coefficient of x. You have to tell me. Okay, this is your question. I will write some terms here. 3x and yx, z square x, 14x. Okay, now tell me what is the coefficient of these terms? Come on, what is the first answer? What is the coefficient of x?
3.
Don't write. Tell orally. 3. What is the second one?
Y.
Y.
What is the next one?
V.
V
to the power
V
2.
power 2. X
14.
14. Here we are getting sometimes coefficient as a numerical value. Sometimes we are getting only variables. Am I right? So here these two are called, okay, numerical coefficient. Okay, numerical coefficient. Clear my point? Numerical coefficient. And these two are called variable coefficient. Just we are giving the name. Okay, variable coefficient. Clear? Is it clear my point? Suppose
Yes.
3yx is there. What is the coefficient here? 3 into y into x is there. What is the coefficient?
3.
3.
No. 3y.
3
I
into
already
y.
told you. Why? Because see, whatever multiple to the a, that called multiple will call coefficient. So our question is coefficient of x. So we have to focus on x only. And whatever remaining part is there, that is coefficient here. Okay? Got it? Is it clear, my point?
Yeah.
There is-
Yeah.
Okay, Harshita, no problem. Okay, always welcome. Right. So these are the, just you understood what is the coefficients here. Okay. Now tell me, I want power value or exponent. Okay, you have to say the power value. Suppose 3 power x power 4 x y. Okay, 4 into x square y. Okay, what is the power? Tell me here. What is the power? Okay, tell me. What is the first question power? Tell me.
4.
4.
4.
Next,
2.
2.
2.
2. Next.
3. 3.
3.
So power of x only I asked here. So you have to say like that. This is clear. Super. Now the very, yeah, what is the doubt?
It's not a doubt, it's a question. Can we do like x to the power of y?
Of course, why not? X to the power of y also we can write. No problem.
So then is that called a numerical power and then a variable power?
Of course, we can bifurcate like that. Then also we can do the, did the separation. Uh, yeah, of course, we can do some separation to the in the terms of numerical and variable. In generally,
Okay.
just we call power. In generally, whether it is numerical or variable, whatever, just we call power. Okay, maybe numerical power. As you said, variable power also there. Okay, clear. Clear, Samrat? Sorry to pronounce wrongly your name. I forgot.
Yes.
Yeah. So this is the way. But why I'm saying all these things, this is the very important. Those who are in sixth grade childrens. Okay. Now tell me, what is the like term? Anybody new? Like term, unlike term. Please tell me the. If anybody knew it, then tell me. Those who are in eighth grade, ninth grade children, I'm asking to you. If you are aware of this, so please tell me.
The like term is 3x x to the power of 3 and 3x x to the power
Okay.
of 4.
Okay. These two are the like terms you said. Am I right? Is this true? What is the unlike term? Alisha, yeah, tell me, ma.
Like and unlike terms would be like 3x and 7x
Yeah,
because
okay.
it's x is only once, but like in the first one, x is being multiplied 3 times by itself, not only once. So they would be unlike terms.
Okay, right. Very good. Very good said. See, here in this case, when we are talking about like terms, unlike terms, we have to observe two things. Okay, what is that? First thing is variable you have to observe. Okay, the next one is power. These two things we have to observe. Okay, when these two things are same in the sense they are not going to same. Actually, my what I'm saying is here. Suppose come to this example. Okay, first variable is same in the both terms. Same in all terms, we can say that all terms. This is the correct truth sentence. Okay. Now let me take this example. Okay. In this example, variables are same. Variable x is same in the both terms. 3x term and
Yeah.
7x.
Yeah.
Yes. Okay. Their power. What is the power? There is a nothing means one is there. If there is a no power, it means there is a one is exist. Okay. Now powers also same. Yes or no?
Yeah.
Yeah.
Then
Yes.
3x and 7x are like terms. Got it my point?
Yeah.
These are like terms. Now come to the above problem. Right. Variables are same. Variables are same. But powers are same.
Yes.
No.
Powers
No.
are not
No.
same.
No.
That means these two terms are unlike terms. Okay, these two are unlike terms. Now you got a clarity? What is a like term? What is unlike term?
Yeah.
Yes.
Yes.
Not then let me ask question to you, everybody. 3x, 3y, 3x. They are like terms or unlike terms?
Unlike.
Unlike.
So
Unlike.
because variables are not very good, very good, very good. Now tell me 3yx, 3, not 3, 14yx. Now tell me these two are like terms or unlike terms?
They're
Like
like.
Like
terms.
terms.
Like
Why?
terms.
Because y variable is same, x is variable same, y power also same, x square power also same. That's why they are like. Okay. Yes.
If it was 14xy, would it still be the same?
Okay.
Because
14y.
it's still x and y.
See the variable xy is the same. Am I right?
Yes, so the order doesn't matter.
No, no, doesn't matter. Why? Because see
Okay.
4 into 3 how much?
12.
3 into 4 how much?
12.
The answer is remain same. So order doesn't matter here. Okay.
Okay.
Right. Good question. Like it. So 14x square, let me take here 3y square x. These two are same, like terms or unlike terms?
Unlike.
Yes, why? Because in the first term, there is a no x term is there. So we can say very easily they are unlike terms. Very good, very good. Keep it up. Right. Now tell me, why I'm saying all these things, Well, because in the addition, it is plays very important role. Okay, in the addition, it is plays very important role. So only two things we are going to learn here. One addition, another thing is multiplication. Okay, right. Actually, we are dealing with multiplications only, but in the multiplications, additions also involved. Okay, why? Let me tell you how it is involved. For example, if you see here, I did addition, yes or no? In this box, you can observe. Yes or no? After doing the multiplication also, I did addition. Got it my point? In the same way, here also we have to do some addition. So that before that we need clarity regarding the addition concept here. Okay? Addition we can do for only. Okay? We can do for only like terms. Only like terms. For like terms only we can do addition. Okay? And you can take subtraction also. Okay? Subtraction also. Clear my point? For unlike terms, we cannot do. For example, suppose 3x plus 14x. What is the answer here? In this case, just you have to focus on the coefficients only. 3 plus 14, how much? 7.
17.
And just you write x. But come to the multiplication, it will be different. It will be different. Observe very carefully. This different, difference is very important. Okay, right. First, multiply these two things. Then how much you are getting? Okay, that is 42. Then we are writing x. Both steps are same. In the addition, we are adding the quotient, and x we are writing. Here also we have numerical terms. The coefficient we are multiplying. After that, x we are writing. But there is a one change is there. What is the change here? We have to add their powers. Add their powers. So these two power must to be added here. So after adding, how much we are getting? 1 plus 1? That is 2. So our answer is here 42x power 2. Is it clear my point? Let me give one more example. Okay. Suppose 5yx plus 5y Not let me take different one. Okay, 6xy. First, tell me these two terms are like terms or unlike terms. First, decide that
Like
they are like or
terms.
unlike. They are
Unlike.
like. No. Who
Like.
said unlike? Who said unlike? I will clear your doubt. Come on.
Yeah, I did because I thought of since there was y.
Order is not the matter, na? Order is the not a matter. So
Oh, a
whether
different.
x is
Okay.
the first term, then y is the first term, doesn't matter. Both are same. Okay, don't confuse. Just we have to
Okay.
focus in the both terms, same kind of variable structure is there or not. Such structure, why I said, sometimes structure, I mean, I mean, perspective, what do you mean by the structure? X square is a structure, I said, right? Because if you see x and square, okay, suppose x power 3 is there, x is there. In the different problems, their shape will be changed. Shape, x square shape is different with x cube shape, am I right? And x width also. That's why I said structure here. Don't take in another scenario, okay?
Okay.
So, what is the answer here we are getting? 11. First, we have to add numericals. Then, whatever value will be there, we are writing x. But in the multiplication, okay, 6xy. The first, what we have to do? The first, we have to multiply numericals. That is 30 we are getting. After that, xy we are writing, but their power we should write. That means here 1, here also 1. So y power is 2. X power is 1, x power is 1. So it is 2. Okay. Now see, I clearly mentioned here only like terms we can do addition or subtraction. But in the multiplication, there is no such rule. We can multiply either like terms or unlike terms also. Let me take some unlike terms here. Suppose, let me write here unlike terms. So 6x square, sorry, y square into x plus 7 x y z, okay, x power 4 yz. Now tell me what is the sum of these two terms. First tell me they are like terms or unlike terms. They are like terms or unlike terms.
Unlike.
So we cannot add. We cannot add. So however, yeah, we cannot add now. So this is the only final answer. There is no change in the answer. Got it my point? If you are not able to add because of their unlike terms, then leave it. That is the answer only. This statement is clear now what I said. Example, the last example I discussed in the addition part. That example is clear for everyone or not?
Yeah.
In case they are not like terms, if you add, if you subtract, there is a no change in it. Got it? That is the answer. But come into the multiplication, the answer will going to change. First, we are going to multiply numericals. Then how much we are getting? 42. Okay. Now, then x is there, y is there, and z is there. Three variables are there. So I written three variables. Now see x power is 1 here. Here it will be 4. So totally how many x's are there? 5 x's are there. So write 5 in the power. Now come to the y. Y here 2 and here 1. So totally 3 y's are there. Only z1 is there. So I can write 1. So this is the product. You got it now? Is it clear for everyone the difference?
Yes.
Yeah.
For everyone, not the few members, for everyone. I want.
Yeah.
Very good, very good. Can I give some examples on it?
Yeah.
is equal to question mark. Is equal to question mark. 12x plus x power 4 y. 6x power 4 into 2x power 5 into x power 3 is equal to question mark. I given you some little bit difficult questions here, but logic is remains same. There is a no change in the logic. Okay, same logic you can apply here. Oh, I got the answers. Good, very good. Srihan. Okay, let me check Sri. Okay. First, focus on the coefficients. Okay, then write the all the variables. But in the multiplications, we have to add the powers of the variable. In the addition, there is no need to add the powers. Okay, come on, do it. In case anybody have any doubt, so please ask me. Okay, because total algebraic expressions multiplication depend upon these two concepts only. If you are not aware of these two concepts, then multiplication become very difficult for you. Yeah, Srihan's second answer also sent. Very good. Avisha also sent the answer. Okay. Yeah, yes.
I'm a little confused on what to do for example 2, the question 2.
Question 2, just I gave you addition of the two terms. Two algebraic terms I given to you. Add it.
Okay.
Yeah, Harshita. Good. Harshita, in which standard do you write now? Which grade? Ninth grade. Very good. Very good. I think you already aware of this concept. I think so. Islam send the answer. Okay. Islam, can you see this board, whiteboard? Okay. And see the difference between the questions? Yes. Okay, good. Okay. Observe very carefully, everyone. See, this question and this question. Observe very carefully. Both terms are same. Both terms are same. The way we are doing the procedures, the steps are so same. But in the addition, okay, in addition or subtraction, okay, we are not adding the powers. Okay, this is the important. Okay, But in this case, we are adding the power. We are adding the power. This is the note. Okay? Right, everybody. Right. The second point is only like terms only we can add. But there is no condition in the multiplication. Here, these two terms are unlike terms. That's why that is the answer. There is no change in it. Got it, my point? So now come to here. Addition, subtraction concepts, combination is there. So 12 plus 3, 15 minus 2. That is 13. After that, what are the variable is there? Just write down as it is. That's it. Now here, xy combination is there here. Here, xy and x square is there. That means they are unlike terms. So in the addition, in the subtraction, we cannot add or subtract unlike terms. So that is the reason xy plus 3y square only the answer. Okay, the come to the multiplication. Multiplication also, see, this is 24. Okay, then variable you can write x is variable and y is the variable there. But what we are doing here, adding the powers here. 1 plus 4 is 5. Then y is power 1. So 1. Now come to the second one. See, here 12x and 2 into x power 4 into y. They are unlike terms, even though we are doing the multiplication. That is the point here. See, here only we can add or subtract like terms. But any term you can multiply. No problem in the multiplication. Whether they are like or unlike. So here come 16 and the 2, that is 32. See, there is a no number means here 1 is exists. There is nothing, no coefficient is there. Okay. So this is equivalent to 1x. And x is equivalent to x power 1. Here I am talking about coefficient. Here I am talking about power. Is okay? Clear my point? Remember this one. Right. So after that, see x power if you count, so x variable is this, I am writing x. 4 plus 5, 8. 8 plus 3 is how much? Sorry. 4 plus 5 is 9. 9 plus 3 is 12. So I want to write 12 here. Now it is clear for everyone? Yeah, no problem. No problem. That is a small mistake. No problem. It is clear for everyone?
Wait, real quick. So,
Yes.
when I said 4xy to the power of 3, was that not right?
You are talking about second question?
Yes.
See, in the addition, I already written here. See, in addition subtraction, we are not adding the powers. This is the condition. What is my point?
Okay.
In the addition, we are not doing. See, very clearly I exhibited here what we are doing in the addition and subtraction and what we are doing in the multiplication. Okay, or else for you, let me write the step by step here. Okay, remember this point, addition and subtraction. Okay, what we need, like terms only. Okay, we need only like terms only. Okay, in multiplication, any terms. Okay, any term you can take, any term. Okay, the next point, powers. We are not adding powers. Okay, let me write simply. We are not adding powers. Here we are adding powers. Adding powers. For example, 4x y square plus 3x y square is there. So they are like terms. That's why I am adding. Here see 4x y square plus 3x y square. Okay, into, this is into. Okay, now see 3 times of 4 is 12. And x, y we are writing, but we are adding power 1 and 1. That is 2. 2 and 2 is 4. Suppose let me take unlike term. Suppose 4x cube plus 10x cube y. These are the unlike terms. Okay. So this is the answer. Why? Because we cannot do anything. But come to the multiplication part. Okay. Then we can solve it. See, 4 into 10 is 40. So x is there and y is there. So now we have to add our powers. 3 plus 3 is 6 and x power y power is 1. So this is the answer. You got the class? No, it is clear now?
Yes. Yes, it's clear.
What about other?
Yeah.